So, this is our topic. It's global climate change. And very simply, what global climate change is if we break the phrase down, is it's global, so it's happening everywhere on the planet. It's the climate, so, and as we kind of talked about, or had seen in the lessons, the climate is the average precipitation and temperature over a 30-year period. So just because you've had a really warm summer isn't an indication of climate change. It has to be like that average change that we're generally seeing, that the temperature is going up every year or going down every year for a long period of time. Like 2 or 3 years of a really good or cold winter is not also an indication of climate change. And that change is more an indication that it's happening on an unnatural level. So it's not a normal change. There are some slight variations from year to year, but this change has to be quite a significant one. So generally that's our topic. We're looking at why we've got this idea of a general climate change over the last few decades, as we'll see in a minute. And why it's important to look at it, as we have these guys. This is this going to right? So this is Extinction Rebellion. They have done lots of protests in London and around the world where they've kind of brought people to like a kind of standstill and tried to protest. And a lot of it was really brought on by this person here. If this moves across. And this is Greta Sundberg, where she was a schoolgirl who started protesting outside the Swedish parliament and refusing to go to school in protest to climate change. It is obviously a bit of a difficult one just now because everyone previously before said they were taking this seriously, and you've now really got to ask how seriously they were taking it, given the response we've had to an actual pandemic and emergency. But it's maybe one to be aware of for later when we look at the solutions of, no, this is serious, we'll take this seriously. But going on to actually how do we know this happens? Because it is controversial. So what evidence do we actually have that shows this? One of the main things we've got is that we have tracked temperature data for the last couple hundred years very accurately, and even for the last 1,000 years, okay. So having tracked this data, we can actually see the significant rise over this period of time. So if we go for where, I need to change colour. Let's go for blue. So if we go from around about here and say we've got fairly accurate temperature data, we can see that the temperature has gone in a general rise upwards. The one thing we can do with this as well is we can also track the amount of CO2 or carbon dioxide in our atmosphere. So if we can also see that the CO2 rise levels have gone up as well. So we can then start to make a connection between the rise of the CO2 and the rise in temperature and say, well, maybe these are connected. Maybe this is what's actually causing climate change to happen. And we're not even talking about big numbers here, like, because if we actually take it across in about 1900, the relative temperature was about, and this is Fahrenheit, so it's slightly less than what Celsius would be like 0.18, and then it's only gone up to about 0.7 in the last 100 years. So there's not a huge change, but this is significant because slow changes are constant all the time. Other evidence we have, and I'm using this example because this is obviously quite a good example of how you can both look at it, is that they've mapped the September ice extent since 1979 very accurately in September. Now, why they always use September was that it was the same time every year, so they could have a reliableness to their data. They say, well, we did it every time. It's not like one year we did it in December where there's been a lot of snowfall, another year we did it in July where it's been really warm. So doing it in September every year means that they can say, wait, this is accurate. However, using September means it is most likely to be the lowest it's ever going to be. So it's just at the end of summer, it hasn't gone cold again, so it's not begun to build up. So it's the lowest it is every year. it's done by like most likely people who've got a bias towards proving climate change exists or making it as bad as possible. But even though that is the case, it still does prove their point that every year in September it's getting less and less. And even some years we might start to see where all of this, you can actually start to sail across up here, where you could never do that before. There is a lot of issues around this, and a lot of things to be concerned about, because if we melt all the ice up here, what we'll find under here, there's a lot of supply of oil, resources, gold, uranium under here. And this is why there was a report out last year that Donald Trump wanted to buy Greenland. Because if he buys Greenland and America have Alaska, then they've got a really good claim on the Arctic Ocean. Whereas Russia have a claim from here, Canada have a claim across here, and even Iceland, the UK, Norway, and Finland have a claim as well. So it's going to be a very contested one in the next few years about who actually owns the ocean under the Arctic. The other bit of evidence we had, and you might have seen or had a look at already, is tree rings. Now, tree rings are maybe a bit more than you might think they are, because they show how much a tree has grown each year. So, likes of, in 1 year, it has grown this much, and it only grows in the summer. So, if it's a really long summer, it will grow a lot more. If it's a really short summer, it won't grow as much. So, if you start getting longer summers and warmer summers that last longer and longer, you'd expect these rings to get bigger and bigger. So, a really short growing season would be about like that. A longer growing season, and then bigger growing season, the tree rings would be further and further apart. Now, this is how we use tree rings as evidence of summer climate change, that summers are getting longer. It doesn't necessarily say how, the reason for them, but just evidence that this actually is happening. The other one we looked at, you should look at with this, is ice core samples. Let's just change this to a different colour just now. So, if we use, they will drill down into the ice and then take out an ice core sample. Now, in all these layers of our ice core sample are trapped, basically pockets or small pictures of the atmosphere over thousands of years. So they will sample one of these layers, and they'll have a look at how much carbon dioxide was in the atmosphere, how much methane, how much oxygen, and then they can take a snapshot of what the temperature was like thousands of years ago. And this all gives us this picture of how we build up graphs like this. And then see that the climate has changed over the last 100 years or so. And the last thing I want to look at in this in terms of today is how the greenhouse effect works. So we've got the evidence that there maybe is climate change happening, but what actually causes climate change to happen? Now, we have these rays that come in from the sun. They go across the vacuum of space, and they then hit our planet and bounce off back into space. Fortunately though, for us, to allow us to live, there is something called the atmosphere and the greenhouse effect, which puts particles up in our air and stops all of that heat from escaping. So it bounces back in and keeps some of the heat in there. Now, we do need this to live. This is a requirement for us to exist on our planet as life. The problem being now is that when we release greenhouse gases such as methane, carbon dioxide, nitrous oxide, chlorofluorocarbons, we are making this barrier bigger and bigger, so it's harder for that heat to escape. And more heat is getting trapped in our planet. Think about it, and if you were doing some exercise and jogging along nicely, and then someone came along and put a big thick jacket on you, it's going to raise your temperature, and that's pretty much what we're doing to our planet, is we're putting a jacket on and raising our temperature to make it warmer and warmer. So here's the actual drawings of that. Our natural greenhouse effect is a very natural thing. It just does happen, and it actually helps us stay alive. There is some natural greenhouse gases, there's some carbon dioxide is there, some methane is there, but it's at a good level. The problem is that we're going from this to this one. This enhanced greenhouse effect, where we're putting more greenhouse gases in and it's blocking more heat so that we're getting warmer and warmer. And really that's the kind of crux of this topic. That's the kind of background you need to know about what's going on. The next part is we're looking on the actual causes, like how we're potentially causing climate change to happen, but we have to look at a physical side as well. But that's the next few parts, and I'm going to leave it there.